Okay, hello students. Today I'm going to show you how to draw the chair conformation for a bi-spiral compound, which I used in our tutorials earlier on. I think it's also great for our other audiences to take note of how can we draw the chair conformation for something that is a little bit unique. Okay, so I'm going to showcase for you the structures on the board first. So that particular compound, if you remember, it looks something like this. Yeah, so it has a middle carbon here, which is tetrahedral. So it's linking the two six-membered ring, but it's not exactly having two six-membered ring together. So it's a little bit different from what we normally expected. Okay, so it looks something like this. Yeah, so this is known as a spiral compound because it has a carbon that links the two rings up together. So it's a little bit different from something like this. Okay, so it's a little bit different. And it's also a little bit different from the decalene which I showcased to you earlier on. Okay, because the decalene which I showcased to you earlier on, I think in the earlier videos, I've already taught you how to draw the conformation. So in this case, we're not going to do this today. We're not going to do this today. This, of course, is straightforward, but I'm going to do something a little bit more challenging. Yeah, so before that, I'm going to show you the model, how we can actually use it. Okay, so the model actually looks something like this. So I already built one halfway. Okay, so something like this, where the red carbon, I mean the red portion represents oxygen, and then these two white portion represents the lone pairs of electrons. Okay, so what I'm going to do here is I'm going to create the spiral compound out. So I'm going to use this carbon to actually connect the other ring up. So I already made one halfway through, yeah, so that's easier for me to connect. Okay, so it will look like this. So I'm just going to put this up here like this, and then I'm going to showcase it. Okay, sorry, I think okay, maybe I should, I think this might be a little bit easier. Yes, okay, something like this. Okay, so okay, so before that, I'm going to showcase two chair conformation. Okay, so that it's easier. Okay, so I'm going to show two chair conformation. Okay, so these are the two chair conformation. Okay, if you cannot see it, maybe I should shift myself a little bit. So you can see one chair conformation here for this particular ring, and then the other chair conformation for the other ring like this. Okay, so I think it's clear enough. So this is one chair conformation, and this is the other chair conformation. Okay, so from here, you notice that in order for me to have the most stable structures, right, both ends must be chair conformation. So as a whole, right, on the whole, there will be three potential conformations which I can draw for this particular spiral compound. Okay, why is it three? Because this is one form, but for each of the chair, right, I can actually do a ring flip. And then after I've done the ring flip, right, you will notice that the lone pairs of electrons are pointing in different directions. So can you see that this lone pair of electrons is now pointing sort of towards, I mean, near you, not really towards you, but near you, maybe on the plane of the board, something like that. And the other two electrons, lone pairs of electrons, is pointing away. Okay, you notice that once I do a ring flip, the lone pairs of electrons will be facing each other. Okay, so I'm not going to cheat here. Okay, so I'm going to do a ring flip. Okay, from here. Okay, so so maybe this is the best way I can do a ring flip. Okay, so I'm going to do a ring flip and you can see for yourself. Okay, so I'm just going to do a ring flip like this. Okay, can you see? So this ring flip, which I did. Okay, and then I'm going to do another ring flip like this. Okay, so can you see that now the lone pairs of electrons is facing each other? Can you see? Can you see that they are directly facing each other? Okay, can. Then I'm going to do another ring flip. Okay, so in this particular ring flip, you will notice that now the lone pairs of electrons will be directly facing each other. Can you see? Yeah, you see, they are now facing each other. So we have two lone pair repulsion. Okay, then earlier on, if I do one ring flip, I have one lone pair repulsion. Okay, then if I do another ring flip over here, so I'm going to do another ring flip over here, there won't be any lone pair repulsion. Okay, can you see? Okay, so now we'll attempt to draw the three chair conformations out. Okay, the three most stable chair conformations out. Okay, so in this case, we'll attempt to draw it. Okay, so let's see what is the best angle we can draw. Okay, because you know sometimes choosing the best angle is the most important in the drawing of this particular conformation. Okay, so I think maybe something like that should help. Okay, I'm not sure, something like that maybe. Okay, so can we try to draw this? Okay, so we'll try to translate this onto the board. Okay, so so when we translate this onto the board, it will look like this. Okay, like this. Okay, and then like this. Okay, and then the lone pairs of electrons like this. Okay, and then the oxygen is here, and then we're going to have this. Okay, sorry, I think my drawing now it's not so nice. Okay, so it'll be like this. Okay, something like this. Okay, so I'm just going to see if it makes a bit of sense. Okay, so I'm going to shift this up a little bit so that it looks a little bit more real. Okay, like this. Okay, like this. Okay, and then of course now the two lone pair is pointing in. Okay, so this is one conformation which you can showcase, which I have drawn for you on the board. Okay, so now I'm going to do a ring flip. Okay, I'm going to do a ring flip like this. You notice? After I did a ring flip, so what happens? So we have one lone pair repulsion, right? Lone pair repulsion. So now we'll be attempting to draw this conformation. Okay, so how can we draw it? So let us try to rotate in a way where we can see something very clear. Okay, so so you can see that you know sometimes it's not that straightforward to draw because we need to ensure that oh yeah, maybe something like this. Okay, can you see? Okay, so maybe I should shift this a little bit like this. Something like this. So we'll try to draw the conformation like this. Okay, yeah. Okay, so now we'll try to draw this on the board. So it'll look like this, okay, like this, okay, and then of course the lone pairs of electrons is here, okay, and then after that we'll try to rotate. I will try to rotate this a little bit and then to see where this is leading me towards. Okay. Okay, like this, something along that. So the lone pairs of electrons will be like this, and then okay, so maybe I need to shift the drawing a little bit so that it looks nicer. Okay, and then like this. Okay, so this is the lone pair repulsion we're talking about. Okay, so I'm going to just showcase to you again. Yeah, so this is what I'm drawing on the board. Okay, and then finally I'm going to do a final ring flip, and then this final ring flip will allow you to see two lone pair repulsion like this. Okay, now can you see the two lone pair repulsion? I think it's very clear cut. Okay, so these are the two lone pair repulsion. So I'm going to draw this structure now. Okay, so maybe something like this. Okay, I'm going to draw this particular structure on the board, maybe on the left hand side. Okay, so so I'm going to do this. So like this, and then like this. Okay, so these are the two lone pair repulsion we're talking about. So these are the repulsion, and these are the repulsion between the two lone pairs. Okay. Then some of you might be wondering, during exam, how can we be able to draw this. Okay, so I think this is not likely to be tested in the normal H3 exams because you really need a model to do a ring flip. But just if you want a little bit of some tips in drawing, I can showcase to you. The main tip actually comes from the middle carbon over here. Okay, and how this middle carbon is bonded to the oxygen. Yeah, so you notice that for the most stable conformation, right? For the most stable conformation, relative to each of the 6 member ring, right? This bond is an equatorial bond. It's a CO axial bond. So there are 2 pairs of CO axial bond for the most stable conformation. Okay. Then for the conformation, which is the second most stable with a pair of lone pair repulsion, you have 1 CO axial, okay, and 1 CO equatorial. How do you know it's equatorial? Because can you see that this is equatorial? In the relative to this ring, this is equatorial, right? Yeah, correct. And then relative to this ring, this bond is axial. Okay, I hope you can see. So again, in this case, relative to this ring, this is axial. Relative to this ring, this is axial. Okay, and then of course, in our case here, the most unstable conformation with 2 pairs of lone pair repulsion, the 2 CO bond, you have 2 CO equatorial bonds. So this is equatorial with reference to this ring, and this is equatorial with reference to this ring. Yeah, so if you can remember in this particular fashion, then I think it will be quite straightforward for you to draw the 2 or rather these 3 chair conformations with a spiral system. Okay, so I hope you find this review video useful for you, and yeah, do keep a lookout for future videos where we'll upload contents on interesting chemistry related matters. Okay, thank you very much.